Welcome back, guys, to Ferkhwa's website. My name is Masoud. I'm a physics teacher. We are in Ferkhwa's website to explain physics curriculum, grade 12. Also, we have an application. You can download it on your cell phone to get our videos. We plan to, let's say, film the whole curriculum for you. In previous lessons, I explained some topics of, let's say, chapter 1. Exactly in the previous lesson, I explained tangential acceleration, and I prepared some questions have to do with tangential acceleration for you. Let's read the question. Question number 1. Which of the following statements describes tangential acceleration? So which, let's say, option is a definition of tangential acceleration? Let's read the option. The first one. A, the instantaneous linear acceleration. Instantaneous linear acceleration directed along a tangent to a circular path. It's true, yeah? It's right. B, the time rate of change of the instantaneous speed in the tangential direction of the circular motion. It's right. Time rate means divided by delta t. Means the phenomenon is taking place during a time interval. That's why, and it says the time rate, I told you, the denominator is delta t. It's clear. The time rate of change of instantaneous speed in a circular track. What does it mean? Instantaneous speed in a circular track means, let's say, tangential velocity. That's why delta vt over delta t. It's true, yeah? So it defines, let's say, the tangential acceleration based on this rule. You can take out the definition from the rule. See, the time rate of change of tangential speed. So it mentions the rule directly. That's why all of the options are true. Let's move on to another question, which is question number 2. Based on the equation, we have this equation, AT is equal to R alpha. Tangential acceleration is equal to radius times, let's say, alpha. Tangential acceleration is space related to what? Related to angular acceleration. Tangential acceleration is, we have a gap here. We have to fill the gap with tangential means AT. AT is related directly or inversely to the angular acceleration, to the alpha. Based on the rule, actually, there is no fraction. They are, let's say, proportional to one another, and directly proportional is true, not inversely. What does it mean? The greater the, let's say, angular speed is, the greater the angular acceleration is, the greater the tangential acceleration is, and vice versa. You can say the greater the tangential speed is, the greater the tangential acceleration is. Right? So they have to do with one another directly. Tangential acceleration, AT, is expressed in. So we look for the unit of tangential acceleration. By the way, tangential acceleration is the linear quantity. That's why it's measured in meter per second square, not rad per second square. That's why the first option is not true. The second option is true till now. The third option, rad per second, is not just, actually, it's not even for acceleration, it's for velocity, for angular velocity, actually, angular velocity, d meter per second, and it's for linear. So the only option, the only true option is B, meter per second square. Let's move on to question number 4, right? The next question is question number 4. Let me read the question for you. It says, if a carousel gap, we have a gap here. The horses on it experience angular acceleration, AT. So if the carousel what? It speeds up, A. If the carousel speeds up, the horses picks up angular angular acceleration, experience angular acceleration. Excuse me, I wrote it here. Angular acceleration. This one should be alpha, yeah, right? Not 80 angular, because it's angular acceleration. If a carousel, right? We have a carousel, we have a merry-go-round. If the merry-go-round speeds up or slows down, right? We have two options. The first option is speeds up. B slows down. C, A plus B means both options are true. For what? For, let's say, for picking up the angular acceleration by the object. D advances with constant speed. So does it make sense to you? Does the object move with constant speed? Does it gain acceleration? I don't think so. That's why the option D is completely wrong. So we have two options here. If a carousel speeds up, acceleration is formed, or if the carousel slows down. Keep in mind that I told you in previous lectures, keep in mind that any change in velocity means acceleration, whether the change is speeding up or slowing down. So guess the option. Guess the correct option. Which option is true right now? So A and B are true, right? Any change in physics, any change in velocity means acceleration, whether the change is decreasing or increasing. Whether the object slows down or speeds up, no problem. It doesn't matter. The object picks up acceleration. Number 5, the most effective method for hitting a golf ball by a golf club is, I told you in previous lesson, I told you about for example, striking the golf ball by a golfer. Actually, the golfer, let's say, grabs a golf club and hits the ball, right? How does this person hit the ball actually? It says the most effective method. Which method is most effective, right, for striking the ball with a golf club? Moving the club. I gave you two options actually in this question. Moving the club in a straight line, normally in a straight line. Just a golfer, let's say, strikes the golf ball normally with a straight line, or swinging the club. Swinging means, let's say, circling the club, actually rotating the club, swinging the club in an approximate circle around a golfer's body. Of course, I'm sure you know the answer because I explained it for you in previous lessons. And so swinging is more effective, right? This is the answer, swinging, right? Number 6, if an amusement park carousel moves at constant angular speed. Constant angular speed. You let's say you hear the constant, right? Concentrate on constant. Let me underline it for you, right? I'm gonna underline it for you. It says if an amusement park carousel moves at constant angular speed. What does it mean? Means alpha is equal to 0. Excuse me, constant, yeah, it's alpha is equal, but it's true, but before I say this, I didn't mean to write this actually. Constant angular speed means omega, look here, omega is constant. Omega is not changing, it's constant. What does it mean? The object moves or rotates or circles with a certain value without speeding up or slowing down. So in this situation, does acceleration, let's say, is acceleration formed here or not? I don't think so. What does it mean? Means omega. If omega is constant, in the case of constant angular speed, there is no acceleration anymore. Acceleration becomes 0 completely, right? Because the object moves with the same, let's say, rate. It doesn't speed up, neither it, let's say, neither speeds up nor slows down. That's why its angular acceleration will be what? Look here. I answered it in advance, right? Let me erase it. I, I, want, I want you to go over it. It says, if an amusement park carousel moves at constant angular speed, omega is constant, the object moves at a constant rate, its angular acceleration will be what? Alpha will be what? Is alpha, let's say, is alpha will be 0? Is alpha increased? Does it, let's say, decrease or constant? Actually, in the case of constant angular speed means omega is constant. Omega is constant, does not change, right? Alpha is not formed. Alpha becomes 0. Figure below shows a rotating object moves at a varied angular speed. So omega is changing. Does acceleration form or not? You have to know this information because it says omega is not constant. Omega is changing continually. It says varied, right? Omega moves the object. Actually, figure below, it let's say shows a particle, an object moves with a varied angular speed. Omega is not constant. Omega is changing. So we have, look here, we have delta omega. You see? And any change in any quantity is taking place in a particular time interval. What do I mean by this? Mathematically means delta omega divided by delta t. So guess the answer. Does acceleration form? Does it, let's say, create or not? So it says a very angular speed along a circular path. Use the figure below to answer the questions 7 to 10, right? 7 to 10. Not 7 and 10, 7 to 10. Question number 7, this arrow represents VT, B, AT, C, VT and AT, D, alpha. Actually, because the, let's say, arrow points, let's say, tangent to the circular track, right? That's why it can't be alpha. I'm not sure right now. Imagine I'm a student, I'm not sure. I say I know this, let's say, tangential speed means tangent to the circular track, no problem. But I'm confused right now. I'm mixed up right now because we have another option that is tangential as well. Tangential acceleration. So does this arrow represent VT or AT? I explained it for you in previous lessons. You have to know this information. Actually, they are different in concept, right? In, let's say, conception, they are different. But in direction and whenever you want to draw VT or AT, let's say it's the same. So this arrow represents VT and AT simultaneously. That's why option C is true, VT and AT. By the way, in value, they are different in value. But in, let's say, in whenever you want to draw a vector, they have the same, let's say, they have the same form, they are parallel to one another, they overlap each other, right? So that's why this arrow becomes VT and AT simultaneously. Number 7, the arrow, I wrote, let's say, the answer for you. I chose the answer. Number 8, the angle between VT and AT is, look here, I told you AT and VT is the same. So we have one arrow, right? We have two arrows, they overlap one another. This is VT and this is AT, for example, right? AT and VT. They overlap one another, right? Only you see one thing. So the angle between these arrows is what? Is it 0? Do you understand what zero angle means? Zero angle means, let's say, parallel, yeah? Two lines are parallel and they are in the same direction, means zero angle, right? 450, let's say, I think this is 45. It's not 400. 45 degree. It's not 45 degree because 45 degree means they cut each other. The arrows intersect each other. It can't be. See 90. 90 it can't be because they are perpendicular. So we don't have this situation here because I told the AT and VT are the same, right? They have the same arrow vector. 180. 180 means parallel as well. Look here. Keep in mind that in mathematics, 0 and 180 means parallel, no problem. But zero angle means what? Zero angle means two things, two arrows, two vectors have the same direction, right? But 180 means two arrows or two vectors, let's say they are parallel, no problem, they are parallel, but they are in the opposite direction. So which option is true? We are doubtful right now about A and D. Whether the option, I'm not sure whether the C, whether 0 degree is right or 180. I want you to guess the answer before I circle it. So I'm sure you, let's say, chose the right answer, which is 0 degree, because AT and VT are in the same direction. That's why zero angle is true, right? Let's move on to a question number 9. Let me read the question number 9. It says, tangential speed or VT and tangential acceleration AT are what? Are gap. We have a space here. We have a gap to each other, perpendicular or parallel. I explained it for you, and I'm sure you know the answer. I say AT and VT, let's say, represent, let's say, one arrow, right? There's one arrow for AT and VT. That's why they overlap one another. So which option is true? Are they perpendicular and parallel? They are parallel to one another. That's why this option is true. Let me circle it, parallel. Question number 10, the object moves. Actually, it talks about the figure. I'm gonna show the figure to you again. The last question. Let me show it to you. It talks about the figure. It says the object moves. The object moves clockwise or counterclockwise. Actually, I read the question for you. Yeah, I read it, and this figure is dedicated for what? For question number 7, 8, 9, and 10. So all of these questions are about the same figure. The last question about the figure, it says the object moves clockwise or counterclockwise. Look here, the object right now is here. It moves up, right? Whenever it reaches, for example, this position, the particle or the object, so it moves to the left. When it reaches here, it moves downward, right? When it reaches the lower point of its track, actually, it moves to the right. So in this situation, guess the direction. It moves like this, against the, let's say, against the clock's hands. Or in other words, we can say counterclockwise. Counterclockwise. So counterclockwise is the true option. Thank you very much, guys, for watching this video. That's it, actually. I want you to watch our next videos, and bye for now.